In this lesson, we'll discuss the reaction of lipids during digestion. The question reads, write the equation for the reaction catalyzed by the enzyme lipase that hydrolyzes glycerol trilaurate during the digestion process. From the question, we're told that a lipase hydrolyzes a molecule. Hydrolyzes means that it uses water to break a molecule apart. So think of a triacylglycerol where it has three fatty acids that are ester bonded to the glycerol molecule. With the incorporation of water and this lipase enzyme, it reverts it back to a glycerol molecule and three fatty acids. So that's what's happening here. Now they're telling us to write a reaction. First, we need to draw out what glycerol trilaurate looks like. I'll begin by drawing out the glycerol part of the molecule, CH2, CH2, and CH2, and we know that there are three ester bonds. From the name laurate, we are dealing with the fatty acid lauric acid. And lauric acid is a 12-carbon chain. It is saturated, so don't expect any double bonds. I'll draw this out where I have carbon double bonded to oxygen, and since it's 12 carbons, that's the first, second, third, fourth, fifth, 6, 7, 8, 9, 10, 11, 12. So I'll draw this out two more times. Now when this interacts with lipase, so we're adding lipase to the mix, these bonds, these ester bonds will break. And this only happens with the incorporation of three water molecules, because the OH from water will end up becoming the hydroxyl of the carboxylic acids of these fatty acids, and this hydrogen ends up forming a bond with this oxygen. This is referred to as hydrolysis, where we use water to break a molecule apart. Question 2 reads, what is the name of the product formed when a triacylglycerol containing oleic acid, and this is incorrect actually, it should be 18 to 1. It has 18 carbons and one double bond. And linoleic acid, 18 to 2, is completely hydrogenated. So we won't have to draw the molecule out here because we know that it is a triacylglycerol, and those always start with glycerol. So glycerol tri something, just like what we saw in question number 1, glycerol trilaurate. With hydrogenation, we use hydrogen gas to eliminate any double bonds. And because they both have 18 carbons, we have to find out the name for the fatty acid that has the configuration 18 to 0. So it has 18 carbons and no double bonds. The fatty acid with this configuration is stearic acid, RIC acid. And since we don't write stearic acid, we write down the ion name, so it's stearate. The name should be glycerol tristearate. And in case you're curious, the common name is tristerin. If you have any questions, please leave a comment below or use our website at biology-forums.com. Thanks for watching.